All right, let's take a look at exponential equations where you begin with the rule and you turn it into a table and a graph so you can show completely what that rule does or looks like. So let's say you started out with something like y equals some number, let's say 7 times 3 to the x power. And then what you needed to do was turn it into a table or turn it into a graph. Essentially, we're asking you to do something where you basically end up with something like this and something like this, right? Now, these are not how to graph that specific equation, but you're building tables, and we need to remember that tables are x, y, and then graphs are all of those points listed out. We've worked with exponential situations before when we did geometric sequences, because geometric sequences follow the pattern of having a common ratio, which is essentially a multiplier where things had a number sequence pattern, like 2 times 3 is 6, times 3 is 18, times 3 is 54, and so on. So that would build a geometric sequence of a number pattern where it was multiplying by 3. We've done that previously. Now we're going to be looking at exponential equations and doing the same thing, but as we said in the last slide, that we're going to be building tables and making graphs out of it. So if you are given a equation that is 5 times 2 to the x power, what we're really doing here is we want to build a table because that builds coordinates that become graphable on a piece of graph paper. We know that this is 0 on the x, this is 1 and 2 and so on. So we know if we take these numbers, we're going to be able to plug them into the equation. We're going to get something that's going to look like this, and then we're going to have a graph that is going to curve up because that's what exponentials do. So what we're going to do is we're going to take each of these numbers and plug them in for x and continue to make the calculation. So you plug 0 in for x, you end up with, if you notice right here, we plug the 0 in, we get 2 to the 0 power is worth 1, 1 times 5 is 5. So the first dot that we would make on our piece of graph paper would be at 0 for the x, and then here is the y, and we'd go up 5. 1, 2, 3, 4, 5, and we'd put a dot. There's our first dot. This 5 is always going to be our starting number. Then obviously if we continue this pattern, we're going to put 1 in for x, and then we're going to have 5 times 2 is 10. So now my next point, we had the 0, 5 right here. The next one is at 1, comma 10, which is up here, significantly higher because it's times 2 larger. Continue this pattern, we'd have a 20, a 40, and an 80, and you should be noticing these numbers are growing rapidly, really fast. And then this is what the graph would then look like, which I was showing you along the way. Now think about where all of the numbers are. So this 5 right here is considered our y-intercept because it shows up as the 0 value across. From 0, we get 5, which that's this point right here, which we call that the y-intercept. Okay, then each of these numbers, this 2 is your multiplier. So you'll notice that as we go through this, this is multiplying by 2 every time. That's what these arrows are showing you. That's where this 2 comes from. Multiply by 2. The numbers get bigger as we go down. So it always starts at your initial value, which is right here, the 5, and this is your multiplier of timesing by 2. Starts at and goes by. And you'll notice these coordinates are just from the table that we made over here. Now, let's try one that shows a little bit of exponential decreasing. Notice the multiplier or the pattern is 1/2. That means we're cutting this number in half over and over again. So I already know I'm going to start at 20 because of this number right here. That's your across from 0 starts at number. This one, the 1/2, that is your pattern. So the pattern is what it's going to go by. So these numbers are going to be decreasing by 1/2 every time. I know my next number is going to be 10. And then I know that if I keep this pattern going, I'm going to have a 5 and so on. So here we go. So I plug in 0. I get 1/2. Any number, by the way, remember, any number raised to the 0 power is worth 1. So now we have 1 times 20 is 20. We kind of knew that was going to happen because it's across from 0, and it's also that number that starts off your equation. Next, we know that we're going to have 1/2 to the first power, which is 1/2, and then 20 times 1/2 is 10. That's where the next number comes from. and then keep this going, and you're going to get 5 and 2.5 and 1.25. Now you can just type this into your calculator in one line of calculator typing. That is completely workable, and you definitely can do that. Now let's take it to the graph level. So we completed the table, which provides us coordinate pair points that we can then graph. So you notice 0, 20 was the first point graphed here, and then the next point was 110, which is here, and then we have the 2, 5, the 3, 2.5, and then we have the 4, 1.25. This is called an exponential decreasing graph because it goes down to the right, and then it's going to continue getting closer and closer to 0 over here. It never hits 0 or crosses 0 on this end. It just gets really, really close to 0 because you're going to have a lot of decimals as you keep cutting things in half. Thank you for watching this video, and you should now understand how to start with an exponential equation and go to a table and a graph.